G'day everyone, how are you going? Video here on examples of integration. Check out the last video, which was on the basic idea of integration. Remember, it's the opposite of differentiation. Integration can be called anti-differentiation, going back the other way. So we've got to be aware of thinking, how would we differentiate that and therefore reverse those steps to get back the other way? Couple of tricks in it, couple of things to see, and I've picked these examples here because they kind of showcase some of the watch out for kind of steps. I left all the simple ones, you can do all those, they're reasonably easy, but I did leave one on here, just here. So I did leave one as kind of a simpler integration, but the rest kind of have tricks in them if you see what we're doing. Let's do this first one. So 3x plus 2 to the power of 3. Well, remember, if we were to differentiate something like this, it would be power out front, lower the power by 1, and multiply by the derivative of the inside. So that means we've got to reverse that. So instead of power out the front, we're going to raise the power by 1 and divide by the new power. So we'll get 3x plus 2 now to the power of 4, and divide by the new power. And we've also got to divide by the derivative of the inside, because our chain rule would say power out front and lower the power by 1 and multiply by the derivative of the inside. So I've got to put this here, because if I was to differentiate that now, the 4 would come out front, cancelling that one, multiplied by the derivative of the inside 3, cancelling that one, and I'd be back to here. Now with all of these questions, and I hope I don't forget on any of these, we do this and we've got to put a plus C on. Now remember, let's just shortcut in the plus C idea. So if I had a graph that looked like this, let's just use a quadratic, let's say. If I had that graph, you'd say y equals x squared. If I had that graph, you might say it was y equals x squared plus 2. If it was that graph, you might say it's y equals x squared minus 3. The plus and minus part on the end is only moving it up and down. It's not changing the shape. So when we differentiate this, now let's just recap a bit of our language, y dash or dy dx, the rate of change of y with respect to x, on both of these, all three of these, the rate of change of x is 2x. If I was to integrate that, I would get back to y equals x squared, but I don't know which one I have. So therefore I put a plus C on here saying I'm not sure. This is called an indefinite integral. I don't know the exact question. I don't know the exact original function, but this says, well, it could be either of these. I don't really know. If you tell me more information, I can work it out, but just from now I can't. So we've always got to remember that plus C on the tail end of any integration we do. That is an indefinite integral, meaning we don't know the complete final answer. All right, this one here. Now, watch this, watch this. I'm going to ignore that there. Ignore it. Pretend it's not there. Two reasons. One is, this is just a coefficient. It's just a number. Don't do anything with it. On all your integration and differentiation, just a number, leave it alone. This x, you might go, but that's part of the function. You can't ignore that. Well, you're right, I probably shouldn't, but I also spot that the derivative of this guy is going to be 2x. And I'm going to have to divide by that. Let's do it. So if we're going to integrate that, I'm going to leave the 20x there. You might disagree for now, but leave it there. X squared minus 7, raise the power by 1, divide by the new power, and divide by the derivative of the inside, and a plus C. Now what you're going to find is that this is 10x on the bottom line, 20x here, so I can cancel that with all of that and just be left with a 2 there. Therefore my answer would be 2 brackets, x squared takes 7 to the power of 5 plus C. And if you're unsure, you can take the derivative of this and you'll get back to here. Moving on, you can rewind this and rewatch it again, of course. Looking a bit crazy, but it's of this style right here. Looking a bit crazy, but it's of this style. So what we need to do here is recognise that that part there probably comes from here somewhere. Now if we were to differentiate that, can you see I would get 6x minus 6? And isn't that a factor of that? Well, it is. Now I'm going to rewrite this to see this a little easier. Let's see, instead of 150, that there is going to be 6 times 25. Okay? And if that's 6 times 25, leave the 25 out there, multiply the 6 in here, and we end up with that guy. That's exactly the same. Just multiply the 6 in. Now I recognise that is exactly the derivative of this. So, similar to here, I'm going to ignore all of that part there. Leave him there for the moment. Don't do anything with it. 25, 6x minus 6. Leave it. This, I'm going to raise the power here. 3x squared, take 6x plus 1 to the power of 5. Raise the power by 1. Divide by the new power. And divide by the derivative of the inside, which is going to be 6x minus 6. We already knew that. And of course now you see that's going to drop out with that, and that's going to cancel, leaving a 5 here. Don't forget a plus c here on the end. I forgot that just then. So my final answer is going to be 5 brackets 3x squared take 6x plus 1 to the power of 5 plus c. Easy again. Do that as a differentiation question and you should end up back here. Moving on, you can rewind. This guy now, this is the trick. You're thinking, what have we got to do? Raise the power by 1, divide by the new power, divide by the derivative of the inside? No. And the reason here, this is the reason you're not going to follow what we did here, is that that is not the derivative of that. The derivative of that is 1. That's not what you've got out front. So you cannot use this idea here of the reverse of the chain rule. Okay? You've got to recognise here, here's the simple thing, just multiply it out. X plus x squared. Oh, there we go. And if I need to integrate that, that just becomes x squared on 2 plus x cubed on 3 plus c. Done. So don't get trapped when something like this comes up and you're thinking, wait, hang on, I've got to do all this fancy stuff. No. Don't miss the simple. Now, you could, in theory, expand out this, multiply it by 20x, get some real long 7, 8, 9 terms, whatever it ends up being, and then integrate. You could, and that would work. But it'd take a lot longer than just doing this. In this case, it's easier to just multiply it out. You just multiply it out, get it like this. Okay, this is absolutely fine. Next one up there, number 5. 5 over x plus 1 squared. Now you're thinking, hang on, what do I do? How do I work with that bit on the bottom line? Well, don't. The short answer is don't. Do this. Multiply it like this. 5 x plus 1 to the minus 2. We can do that. We're just bringing it up to the top line. Now I can follow a similar sort of process, not quite the same, but a similar sort of process. Raise the power by 1. Now, always remember your number line. Here's 0, here's minus 2. Raise the power by 1 takes me to minus 1. Okay, raise the power by 1. Oftentimes people mistake that. They think, oh yeah, that becomes minus 3. No. So raise the power by 1. So we've got 5x plus 1 to the minus 1. Divide by the new power and divide by the derivative of the inside. But in this case, it's just 1. I'm going to write 1 so that you don't forget about that part. It doesn't have any effect here. Now, let's tidy all this up. This is just minus 1 on the bottom line, so I can bring that minus up to the top line. So I could write minus 5 on the top line. And this part here, because it's a minus 1 power, it comes down to the bottom line, x plus 1. Now, you don't even really need it in a bracket because it's only to the power of 1. And I should have put a plus c here, so I'll tuck that in right there. So a neat little question there. Next one, this. This is really a combination of this question and this question. I'll just pause a moment, see if you can see that. It's a combination of that one, number 5, and this one here. Now, why is it a combination? Well, we've got something on the bottom line, just like we did here, but we've got a factor of 18x, like we had 20x here. So we've got to kind of meld the two together. So do this step first, okay? Rewrite this as 18x brackets x squared minus 3 to the power of minus 4. And then once we've got that, we can then kind of just do this, but forget about this guy for the minute. Don't worry about him, right? Just like here, I forgot about him. Don't worry about it. So, raise the power by 1, minus 3. Minus 3 is raising the power by 1. So this becomes x squared minus 3 to the minus 3. Leave the 18x out the front. Divide by the new power. And divide by the derivative of the inside. Alright, I'll just change that x to a curly one. So on the bottom line I've got minus 6x. Here I've got 18x. So I'm going to cancel that and that. In here, 6x divides in there 3 times. Now because I have integrated, I should put a plus c here. Now I'll squeeze it in down below there. We're going to end up with minus 3, I'll move this minus up to here. I'm going to end up with minus 3 on the top line. Let me move him over. Minus 3 on the top line divided by, that whole thing can come down below. X squared minus 3 squared plus c. Alright, very similar question to this and this. Hopefully these have helped you. I'm going to do another video. I'll choose some other questions that are kind of tricky ones. We'll call this examples of integration part 1. There we go. I'll do part 2 in a minute. See you later, guys.